Well, hi everybody. Need to start the countdown timer as well. My name's James Bottomley, and I'm actually talking to you today about the diary of a drive-by coder. And what I mean by drive-by coder is someone who's not a specific core member of a project and yet is trying to get patches upstream into that project. One of the reasons I got leaned on heavily to give this talk here is because although I can outline some of the strategies that I use to try and get patches upstream successfully, there is no one successful strategy. And there are definitely communities that are highly resistant to accepting patches from outsiders. And actually, for me, there's an added difficulty in that there are a lot of communities interested in proving that they are better than the kernel. And so when you come to them as a kernel developer, you have to work twice as hard to get your patches upstream. But the point is that everybody who comes to Linaro as an engineer is actually trying to, in some sense, get patches into open source projects, and all of us experience failures along the way. And hopefully by telling you some of my failures as a nearly 30-year kernel developer, a guy who's actually advocated for upstream at other companies, set their upstream strategy, been the one person pushing all the engineers to do it, it's still sometimes impossible for me to get my patches upstream. So this is a demonstration of some of the failures as well as some of the successes I've actually had. So a bit more about me. Apart from sort of doing open source at companies for a long time, and that really means acting more like a community officer or trying to enable other engineers to do open source rather than actually pushing all the patches myself. I've been a kernel developer for enormous time. I've been the SCSI subsystem maintainer since 2002 and the PA risk architecture maintainer for almost as long. And in 2011, I was one of the people instrumental in getting the container agreement at the kernel summit. So I am deeply embedded in the Linux community. The drive-by coding I've done has actually been interesting. The one that you probably know about is the Android cyanogen mod. Right back in the early days of Android, and we're talking about 2.3 here, which dates me, in order to prove that I still have my 2.3 based phone. This is an Android Nexus 1 that I still use. And my contribution mainly to cyanogen mod, because it was very difficult to get patches up into the Google AOSP project at that time, is OpenVPN. The reason I needed OpenVPN is because I had to get email from a corporate server that was behind a VPN-based firewall. And this was the very early days of Android. Now, you'll probably have heard a lot in the media about communities being Wild West in the early days. But to me, when I look at what Wild West means, it actually just meant that we were so hungry for patches that we'd accept them for almost anywhere. So I won't be talking about what I did for Android because it's actually somewhat embarrassing compared to the processes you go through nowadays. Presumably all of you know about Gerrit and the dedicated reviews and everything. I got these patches up into CyanogenMod by opening a Bugzilla and attaching the patches as attachments and saying this will make OpenVPN work. And in those days they accepted them. I'm fairly sure in these days they would not. The second piece of patching I did for the Android ecosystem was actually in Java. So now you can say that you have at least met one kernel developer who knows how to program in Java and will admit to it in public. And what I did was I needed a SIP client for Android that would actually plug straight into my Asterisk system at home. And in those days, the SIP client for Android that was open source was something called SIPDroid. It's now been rebranded as Lumicool, but it's still actually available in the Android store, and the additions I did for it are still actually available as well. I must confess I have two patches for SIPDroid. One makes the codec support pluggable, and I needed this because in a lot of situations where I wander around the world, you get to hotels, some of which have really unfortunately crappy networks. You don't experience that here, but in a lot of the hotels I've stayed in, it's true. And there are certain voice codecs like Opus that are actually very accommodating to horrible networks. And so what I actually wanted was to program my Asterisk server and the phone to actually agree a set of codecs that I thought would work with the hotel's Wi-Fi. And so the pluggable codec support, if you look at it, is primarily SPX and Opus, which is its replacement now. It's got a few of the other high-definition audio codecs, and then it just has the usual ULAW, ALAW stuff. And it allows you to reorder the codecs in the order you want them and to turn them on and off, which means that you can actually set the preferential order that the SIP-Droid client will offer to the end device for the codecs it wants. And that means you can pretty much control what codec you're actually going to be using. I've also done libical time zone fixes. This is because I had to use, I've worked at a lot of companies where Exchange is the standard calendaring system. Evolution connects to Exchange, but it had certain time zone issues. Time zone issues are interesting when the actual country you're working for re-legislates its time zone. So this happened to me when I was working for Parallels, and Moscow, Russia, has changed its time zone 3 times in the time I've actually worked at Parallels. The first time it officially abolished summertime. The next time it officially switched to summertime, and then it decided that it was too dark in the morning, so it officially switched to an hour earlier than summertime, so it would be lighter in the morning. And each of those times, Evolution really did not cope very well with what was going on, because the fundamental time zone files were actually changing underneath it. And this annoyed me, so I had to fix it. I've also done a lot of other Evolution fixes. Like everybody in coding, for drive-by coding, I'm actually mostly just a user of the platform. So I'm a user of Android, I don't really code for it. I'm a user of Evolution, I don't really code for it. But if something goes wrong, I'm also a programmer. And that means that if it goes wrong and the rough edges annoy me enough, eventually I will actually download the source code, pull it apart, see what's wrong, and fix it. Now, for me, there is a wonderful system called the Openssl build service, and I run SUSE. So all I really do is I add my fixes as patches to the RPM and put it upstream into the Openssl build service, and it will just keep building as I keep updating. And if eventually my patches don't apply, it will tell me. So this means that it actually provides me with a fairly low friction way of getting my fixes to work for me alone. But obviously, as a community person, I do see it as my duty also to try and get these things upstream. And actually, of all of the patches that I'm listing here, apart from the TPM enabling ones, they're all pretty much upstream. I do have a dirty secret in SIP-Droid. As well as codec support, I actually also got Bluetooth working for SIP-Droid. Because I like using Bluetooth speakers and headsets, as we'll get onto. And I must confess, I haven't actually even posted that patch upstream yet, so I'll make a note to actually get on and do it. So let me give you a bit about what this talk is not about. Because I'm talking about drive-by coding, most of what you hear from your community managers is how to build long-term relationships with communities. And the reason they do this to you is because it is the best way of getting your patches upstream. If you're a member of the community, they are much more willing to listen to you than if you're not. So if you have the time and the effort, and you're going to be making long-term, ongoing contributions to the subsystem, you need to build long-term community relations. Now, I say that as that should be your #1 thing to do for most companies, because most companies are not really doing drive-by coding. Usually, they actually want to be involved in the ecosystem. But this is a tangent for me because I am talking to you about drive-by coding. So this is actually about finding something that's wrong in a specific project and fixing or enhancing that one thing. And although most corporations that you work for in the long term do want to be members of communities, there's always that thing on the side that you need to work for your release that doesn't quite work, that you have to fix. You find that it's a bug in whatever it is, you fix it, and then you need to get that fix upstream. That makes you a drive-by coder. It won't be a big part of your job, but it will be some part of your job. And I'm actually thinking the term drive-by, given what's going on in the United States, is somewhat of a loaded term now, and possibly, I can probably get away with it here, but I can see a time when it will be outlawed by the Code of Conduct. So I'm thinking of altering this to single-issue committer instead of drive-by coder. So how I got into all of this. I can't remember where I put my bag now. So all I have is the actual picture of what it was. I actually have one of these in my bag as well. That is a UE Boom 2 speaker system. They're one of the best stereo speaker systems that operate over Bluetooth. So the design of this thing is that you just attach it by Bluetooth to your computer. It uses A2DP to actually do 2 stereo audio channels with the SBC codec, and it produces really, really excellent sound quality. It's actually brilliant for listening to stuff. Pretty much, I only use it for listening to stuff when I'm sitting in the bath. This is waterproof, and watching films on Netflix. Most of the time, this thing is also a headset as well. It actually acts like a hands-free headset. And so it will actually do a very high quality surround sound speaker and microphone for a conference system. So this thing is actually so powerful that I can take a room full of people who basically have never been able to get the video conference system in the conference room working, plug my laptop in at the front, turn its camera on, project the screen, and then stick this thing in the middle of the table, and at least 10 to 15 people can just sit around this and still have a reasonable conference call conversation. It's actually a very good piece of technology for someone who's always on the move and who always has technology difficulties. But there's a dirty secret to this thing. The speakerphone doesn't work with Linux, and there's a very interesting reason for that. The problem is that if you look at our current Bluetooth system in Linux coupled to PulseAudio, what we expect is that all headsets, which are things with a microphone and a speaker, speak what is called the Bluetooth headset protocol. Unfortunately, this thing is one of the few speakers in the world that doesn't do that. It actually doesn't have the identification endpoint for the headset protocol. All it has is the identification headset for what's called the hands-free protocol. Now, this is not uncommon if you go to the automobile space. All of your cars only have the HFP protocol. None of them have the HSP protocol. And the reason for this is because the hands-free protocol is designed not only to be an audio channel, but it's also designed for all those little buttons you have on your steering wheel, and it's designed for incoming call notifications. It actually makes your Bluetooth headset much more sophisticated. And actually, one of the things I use this UE Boom 2 for as well, since I travel around the world an awful lot, is that every time you get into a rental car, you usually spend 10 minutes mucking about with the Bluetooth system just to plug your damn phone in. For me, what I do is, my phone is paired with this thing, so I just put it in the cup holder and turn it on, and it will play to me my podcasts, and if I get an incoming call, I've actually got a button on the top of the phone that I can just press and answer it. And because its surround sound is so good, I can actually talk in a car environment as well, and amazingly enough, people can actually hear me very well. So now I've got out of all of the plugging my phone into strange cars at airports problem as well. But the issue in Linux is that we just don't have a connector in PulseAudio for the hands-free protocol. The only connector we have is actually for the headset protocol. And so what I did a long time ago is analyze what the problem was and just made it all work inside PulseAudio. It sounds to be a fairly simple thing. It's actually not. One of the differences between the headset protocol and the hands-free protocol is the headset protocol is just a configuration-free plug-and-go protocol. That's why we use it. The headset protocol. The hands-free protocol is actually a protocol you have to configure over what's called the RFCOM channel. The RFCOM channel is a little modem channel that sits off the side on Bluetooth and accepts AT commands. And you have to send a sequence of AT commands to this thing before it will actually start to understand what you want to do with it and connect correctly to your audio system on the other side. So one of the things I had to do when I actually made this work was to put a small RFCOM parser into PulseAudio to actually do the negotiation, which is a somewhat complex negotiation. So the code is, it's about 100 lines long, but it has bits where, you know, you might be at this version of HFP, so I have to do this, but in this version of HFP, I have to do that, and so on. But I have it done, and it by and large all works now in PulseAudio, which is why I can use my UE Boom speakerphone connected to my Linux machine as a conference system. But this isn't what you want to know. You want to know how I managed to get the patches for this thing upstream, which is what I'll actually talk to you about. First of all, you need to understand that when you talk to communities, not all communities are equal. In fact, they have many different traits and characteristics and quirks. It doesn't just go to whether you're GitHub-based or whether you like Gerrit or whether you prefer GitLab or whether you're mailing list-based. There's a fundamental philosophical difference that divides two communities, and it's called the our code versus your code difference. And what actually happens is that in your code communities, the code is thought of as belonging to you, right? If you put it up into the project, it's still thought of as being your code. And the question your code community usually asks is, when you give us this code, are you going to disappear? Which is a very difficult one to answer for a drive-by coder, because the answer is, of course I'm going to disappear. As soon as I've got this upstream, I'm off onto my next project. And that answer is somewhat of a blocker. So the next question they're going to ask is, can we maintain your code? Is it well written? And if they can answer that affirmatively, your code communities are, by and large, often happy to actually just take your code. That's what happened with the Android code for OpenVPN, the SIP-Droid code and everything. If the code is good enough and clean enough and it looks simple enough, usually they'll just take it, even if you can't give them a guarantee that you will hang around in order to maintain it. And you can always say things like, well, I won't be working on your project, but if you have a bug report, I'll be happy to handle it. There are mitigation strategies for this problem. But in a your code community, it's convincing the community that this code is not just going to explode, bit rot, and cause damage to the project. The other type of community is what's called an our code community. This community thinks of the core product as belonging to them. And the them can either be the entire community, of which you're not a member if you're doing drive-by coding. That's a fairly nice way to look at an our code community. Excellent example of this would be something like OpenStack. But then there are also communities that maintain sort of technical oversight boards or cabals or, tiny coteries of people sitting in the center of this community who also think this is our code. We are the guardians. And for that type of community, the main problem is proving that you are actually worthy in the first place to submit this code. Because they have a sort of mentality that, our project represents the pinnacle of perfection. Any code we accept from the outside, from someone who is not part of our community, is ipso facto bad code, and you have a really high burden to prove to us that you are actually worthy to submit this code. The best example of an our code community that I've had to deal with would be something like Openssl. It's a CII project now, but it has a core set of committers who spend all of their time reviewing other people's patches. It's certainly not impossible to get your code upstream into this community, but they do certainly make it very difficult. My difficulty was somewhat more related to other issues that I'll get onto. But the basic problem is that our code communities are almost always unwelcoming to drive-by coders, which is a pity because most of your bug fixers and people who spot issues in code tend to be drive-by coders. So in theory, if you're unwelcoming to drive-by coders, you're inviting more bugs into your project because you don't actually let people who have an interest in fixing them fix the bugs. But like I said, just because you found an our code community doesn't mean it's a lot easier. They'll still be asking awkward questions like their suspicion of where will the maintenance burden of this code be. So you still have to convince them that your code can be maintained by the people who actually run the project. The problems are not entirely dissimilar. So a problem ignored is a problem solved. The first PulseAudio patch set, Do This Bluetooth Speaker Thing, was published in August 2016. That's over 2 years ago now. It's a good mailing list, so we had a good discussion. I did code changes based on the discussion. But eventually, just the thread fizzled out. The interest got lost, everybody ran out of steam, and nobody responded to the last post I did, and you think, okay, what do I do now? And I would imagine almost everybody has been in this situation. Even when you're trying to become a member of a community, this is, by and large, the response to the first patch you ever submit. And so what actually happened is I disappeared. I sort of thought, okay, I'll wait and see what happens. And what actually happened is I got a mention in the PulseAudio wiki. You can actually see it there, where they say they'd really love to be able to use this HFP stuff without Ophono. So Ophono is it's actually a modem emulator for a Bluetooth system, and there is an incredibly complex and difficult way of attaching PulseAudio to Ophono such that it will actually plug into an HFP headset. As far as I can tell, only one person in the world has actually ever got it working and demonstrated it, and it's definitely not something where you fire up Bluetooth, turn on your headset, and away you go. But what they said was, getting it to work without Ophono would be nice. I've submitted patches for that. The patches need some work. Help with finishing them would be appreciated. And I looked at this and thought, but I interacted with the mailing list. I addressed all of your points. What is it that you want me to do that would finish these patches? And so this is where we get into a situation where there's a mismatch in communication somehow, and it's a mailing list. I go back over the archives. I couldn't really find the mismatch, but there is definitely a mismatch there between their expectations and what I've done. And trying to bridge the gap involves actually trying to establish what this mismatch is. Now, as far as I can tell, the mismatch is not entirely technical. It's also to do with the fact that somebody in the community is very wedded to the way Ophono does it, so they're reluctant to actually accept a patch which would basically kick Ophono out of PulseAudio. And it wouldn't do it immediately, so I was very careful to be, nice and listening to their community. So the patch itself coexists with all of the Ophono code that sits in PulseAudio, and I gave them a nice switch, and the switch can be done at PulseAudio startup time, or it can be switched dynamically in PAVU control, but there was an argument over what the default should be. Should the default be the easy code or the hard code? And you can guess I wanted the easy code and some other people wanted the hard code. I think the default is basically the point at which this is what needs to be finished. Okay, so a year and a bit later, I did another repost on the 20th of September 2017. The reason I did this repost is not because I'm such a wonderful community person. It's because, as I told you, I use the Openssl build service. So it just goes along and pulls down the latest PulseAudio, applies my patches, and rebuilt it for me. And there was a point in August where this broke. Something had changed in the PulseAudio code base that was conflicting with my patches. So I actually had to go back, pull down the code base, and rebase my patches to work for this, work out what the changes were. And there were actually some, it wasn't a simple rebase, it was actually something that actually I had to redo coding for. And in the course of redoing the coding, I realized I had a couple of mistakes in my patches that they hadn't even spotted. So I fixed that. The mistakes were actually in the RF-COM negotiation, so presumably no one had really tried this. It turned out that the negotiation was very highly tuned to my UE boom device. And in 2017, I acquired a second Bluetooth device that didn't work with these patches. And investigating why not allowed me to work out what was wrong with the negotiation. So I actually fixed the negotiation as I did the repost. But the repost was basically because my build service broke and I had to fix it, so I fixed it and then reposted the patches upstream. Like I said, I fixed up the code, polished up the code, fixed bugs in the original protocol negotiation, told them all about it, and the objection is still the Ophono people don't like it. This time we actually did have an explicit argument about what the default switch should be. And again, everything fizzled out because the leader of the community, I think, understands that to be useful, it would be useful to have this code as the default. But the PulseAudio, the Ophono people really don't want that. But if we put it as their default, then it becomes a configuration burden on the distributions to get everything working again. And there's another underlying issue, which is that if everything works simply with my patches, why would anyone ever need Ophono? So if you're a member of the community that likes Ophono, you can see a straight line path from accepting these patches to your cherished subsystem being declared obsolete by the maintainer of PulseAudio. This isn't a technical problem. This is really a deep-seated community personality problem. These are the most difficult problems to overcome. But of course, the result is deadlock. The way I would have broken this deadlock if I could was if we actually had a significant community of people who had the same problem as I did. The issue is that almost every Bluetooth device, even the Bluetooth 4 and 5 devices that are delivered today, have both the headset protocol and the hands-free protocol. So almost every Bluetooth device delivered today, bar my one speakerphone, works out of the box with Linux. So there is no significant community pressure to solve this problem. Perhaps one day the HFP protocol will take over and there will be significant community pressure. But without a community to back me and say, you know, I've got a device and I have this problem, and I have a device and I have this problem, we're stuck in the rut that it's basically only me with the problem, and by and large, I use my build service, so it's solved for me, so I have some pressure to push, but not a huge amount. The converse of this is that if you are trying to get patches upstream, and you're trying to do it as a drive-by coder, one of the best ways of doing it is actually to find other people who have the same or a similar problem with you, form a community with them, and get them to support your patches on the way up. It's actually a wonderful way of convincing the community that it's more than just one annoying individual who wants these patches to be placed upstream. And to be honest, when I worked at Parallels, this was largely the way that we got most of our patches upstream. Even in Linux, I can't just say, I'm a Linux maintainer, take my patches. We have to make a technical argument for it. So all of the container patches that Parallels did, part of the reason for the agreement at the kernel summit, there'll be a single container system, is that now we have a ready-made audience of several big companies like Google, Facebook, and so on, who are very interested also in helping get container patches upstream. So if we have difficulty on the mailing list or we get non-technical objections, we can wheel out the community to actually support these patches, and that often helps in actually getting them all upstream. But the result in the PulseAudio case was deadlock, and I suspect there's actually, it looks like they don't like the code, but I suspect there is a really deep-seated issue here that I just don't have the tools to solve. Okay. Let's move on to a different type of community, OpenSSL. Oh, by the way, PulseAudio is very much a your code type of community. So it's one of the should have been one of the easier communities to get stuff up in. But I did the PulseAudio example just to show that even your code communities are not perfect for actually getting stuff upstream in. So this is my failure, PulseAudio. The patches are still out of tree, even if I do have a Bugzilla, a wiki mention on them. Next community is OpenSSL, which is very much an our code community. The initial problem, as I saw it with OpenSSL, is they have an API bug. So what I'm trying to do in OpenSSL is to enable what are called TPM key files. So if you've ever used OpenSSL for creating X509 certificates, you know that when you create a certificate and a key, you get two files back. They're usually PEM encoded, which is type of base 64 encoding of ASN1. You don't need to know any of these technical terms. All you need to know is you get two files. One represents your certificate, the other represents the private key for your certificate. The private key is often password protected, but once you type in the password, it's decrypted, the private key is out in the open. There is a way of using the TPM that sits on all of your laptops to actually transform from a raw private key to a TPM form of a private key that then cannot be abstracted from your system. The TPM form can only be understood by the TPM itself. All crypto operations now go through the TPM. You just feed the private key into the TPM and tell it, I'm this person, make me a signature, and it will make you a signature. And the reason this is useful is because once the key has been transformed into the private form of a TPM on your laptop, it is useless to anybody else in the world. Unless they possess your specific TPM, they cannot use it. So it's a very good mechanism for actually making your keys unique to you. The only way that somebody can actually impersonate your identity is by logging onto your machine, using your TPM, and using the key file in your authorization, which is like the passphrase you used to have for decrypting files. So it's actually almost equivalent to a two-factor security measure for your keys, which is why I use it. The mission I was on for OpenSSL was actually just to try and TPM enable it. The way you TPM enable it is through what's called engine code. Engine code is really what OpenSSL calls plugins. So I just wrote the plugin. But there is a problem in the OpenSSL API in that the API you use to load the key file is specific to the key file. So there is an API for loading a PEM key. There is an API for loading a dir key, and there is a separate API for loading an engine key. Sounds very well, but when you write code using OpenSSL, you often forget there are two different types of keys, even dir and pem. Usually you've only used one of these APIs. This is why if you create a dir key and try and feed it into OpenVPN, it will error out. You have to have a pem key because they only used one of those APIs in the OpenVPN code. So I looked at this and I said, but we can always tell based on the file headers what is actually going on. Why don't we just round robin through each of these APIs and just have a single load file API that tries each one sequentially, and if one succeeds, we call it a success. And I thought, this is actually a nice, simple solution that will fix the world for OpenSSL. It's going to be brilliant. Well, so I took this proposal to the OpenSSL list, and basically, this is an Our Code community that is very proud of their code. At the time I took it to them, they were basically just coming back out from being beaten up by the CII for having almost no testing and exposing the world infrastructure to a lot of bugs because there were problems with OpenSSL. So they were very defensive about their code. And defensive people do not take kindly to you telling them that their API has been wrong from the get-go and it should be fixed like this. So the problem I had is that I can't get this API change up to Upstream without Upstream admitting that there was a mistake. To commit my change would be to admit that the mistake existed. So we're all backed into a corner where they, just for the sake of their coding honor, cannot commit my change, and there's nothing I can do to get it upstream. Although we went round and round for a while with the arguments getting more and more acrimonious until you get the ultimate death knell, which is, one of our trusted committers has a speculative API that isn't upstream yet, but which you could use. This is the invitation to take somebody's weird design document that's written on the back of a napkin, and if you implement all of this, you will be worthy to get your code upstream into our community. And all of this, for me, was actually a huge thing. It's now in OpenSSL as a store API, but if you look at how big that is, this would have been a massive amount of code. So I have a simple fix for what I think is a simple problem, and now the offer back to me is basically devote a year of your life to working on our code, and then the problem will be solved and everybody will be happy. And it's sort of like, well, okay, thanks guys, but no thanks. So basically, OpenSSL is still a problem. What I actually did was from that point, I know that I'm never going to get anything useful out of the OpenSSL community. So what I did is actually just move one level down. If all of the code that's using OpenSSL is usually using only one of these APIs, go to the projects I'm interested in, which for me was OpenVPN, and OpenSSH, because I wanted my VPN keys and my SSH keys to be TPM resident, and just persuade both of those communities to use all of the APIs so that any key form works for them. So that's the actual route that I'm currently embarking on for crypto subsystem enabling. However, there's another more wonderful thing that can happen to you as a drive-by coder, which is when an adjacent community looks at what you're doing in drive-by and comes to you and says, could you do this for us? So it happened at Kernel Recipes last year. Werner Koch asked me how we could actually use the TPM for enabling GPG. And I'd actually thought about this problem, but hadn't really done anything about it, because TPM code has to be crafted specially for the crypto system you use. And I looked at OpenSSL and figured that most crypto systems in the world do tend to use OpenSSL. A few use GNU TLS. GPG is the one exception because it has its own crypto system called libgcrypt, which pretty much isn't used by anybody else. And I hadn't even got around to looking and seeing what it would take to TPM enable libgcrypt. But Werner asked me to do this at the conference, and the result was actually an agreement to code a TPM module for GPG2. I showed this prototype in person at FOSDEM this year, so we've gone from, the timeline for this is Kernel Recipes is in September. It will actually be next week in Paris, so that's just 1 year later. So we got the agreement in September. I was already showing the prototype in FOSDEM, which is in February, which is really about 5 months from doing it to coding. The result of this is that Werner actually rather liked the prototype and how it had been shown, so I actually have a TPM work branch in his tree that I can send patches for, although right at the moment he hasn't been terribly responsive to the patches, but he's a very overloaded type of guy. It's not upstream yet, but having a branch in somebody else's tree is a definite promise of upstream soon. So this is one of the results that is a strategy for getting your stuff upstream. So if you can convince the community that they really like what you're doing and it will really be a feature that actually enhances their code, they can actually get on board with having you do whatever you want to try and enable them to do this. That's what happened in gnupg. They had also thought in their own way that it's really stupid that we have a key handling system and every laptop on Earth, well, bar Apple Mac laptops, has a TPM that can actually afford us a vast increase in terms of key security, and we just can't use it. So when this weird guy comes along with his TPM enabling quest, you look at it and go, well, could you do that for us? And the result is that, I mean, in fact, they had to ask me. I assume if I'd gone to them, they'd have pretty much bitten my hand off, but they had to come to me and ask me to do it. But once they did, I was happy, they were happy. We actually have an agreement that actually allows rapid and useful forward progress in doing all of this. This is one of the best ways of actually getting your code upstream, convincing the community that they really, really need it. You can't do it all the time, but it's actually a very good strategy to employ if you can do it. Of course, there are my kinds of communities. I've done quite a lot of drive-by coding for the Linux kernel. When I say drive-by coding, the kernel is not a single monolithic project. It's effectively a balkanized set of maintainer-driven projects, each of which has its own separate rules. So just because I know how SCSI patches go upstream, because I'm the gatekeeper for them, doesn't mean that exactly the same process is applied by any other subsystem, because it's not. So in order to apply patches for another subsystem, I still have to learn a different set of coding rules. So in the kernel, I've actually done an awful lot of TPM work, including a chunk of the in-kernel resource manager, which is a very important component in the kernel for actually adopting TPM 2.0, which is just percolating through our ecosystem now. And this, for me, was definitely not plain sailing. The TPM subsystem has what I would think of as incredibly weird rules, like one variable declaration per line. Well, it's annoying to get your patches kicked back going, you do not do int a, b, c. You have to do int a, semicolon, int b, semicolon, int c, semicolon. All it is just, it's one maintainer's sort of foible about how they want the code to look. This is a very controversial topic. I bring it up just because I can give you something to titter about. This actually is not a fault of the TPM subsystem, so don't lay this at the door of the TPM maintainer, but it is a fault of the network subsystem. If you want to get a code, a patch up into the networking subsystem, you have to understand what reverse Christmas tree is. What reverse Christmas tree means is that all of your include files have to be ordered in reverse by the length, with the longest one at the top and the shortest one at the bottom, so it looks like an upside-down Christmas tree. When I first saw this coding recommendation, I actually thought it was a joke. I did check to see if it was April the 1st, but apparently it's a real foible of the maintainer. You want to get your code upstream in the network subsystem, you have to order the includes in reverse Christmas tree order. There is no way around this. If you don't do it, you're going to get your patch kicked back with a note telling you to do it. For me, in the kernel, prior reputation helps an awful lot. Because I'm a kernel maintainer, it is easier for me to go to other kernel communities and say, please will you get this code upstream. I believe I actually do have one patch in the network subsystem that violates reverse Christmas tree. And I think Dave Miller reminds me of this every time I see him for a beer. And the only reason he did that is because he likes me. So prior reputation can help a lot, but if you don't have a prior reputation, you do have to respect the norms of each of these communities. Prior reputation only matters if the community respects it, so you also have to be slightly careful which communities you join. In the early days of OpenStack, I had a lot of difficulty with the OpenStack community because as CTO of Parallels, my job in those days was to actually get us gold membership in OpenStack, which means being nice to OpenStack. And OpenStack was on a bender from several of its members to prove that it was a better community than the kernel. And the way it wanted to prove this was by evolving coding mechanisms that actually looked at the kernel and thought we can do better. So they were all slightly different. So I had this suspicion of, well, you know, we don't really like the kernel community. Should we be accepting a code from a kernel community, or should we even have a kernel community guy actually coming to us and helping us with advice? Because it was basically, we were looking for a gold membership and a board seat. And so I wouldn't even be contributing in a technical capacity, I'd be contributing in an advisory capacity. Fortunately for me, it turned out there was an issue that I could align OpenStack up on, or align with OpenStack, and that was this thing called the DCO, the Developer Certificate of Origin, which OpenStack, there was a definite movement in OpenStack to try and get rid of what's called the ICLA, the Individual Contributor License Agreement, because it was seen as a huge barrier to contribution, particularly drive-by contribution. So OpenStack was trying to make itself a more welcoming community to drive-by contributors. And so the way I actually got into OpenStack was by saying, well, the kernel originated the DCO, but it wasn't all smooth sailing for us. Let me have lots of meetings with you about how we did it, and I can give you our experiences, and you can craft your own mechanism for OpenStack, which will allow you to adopt the DCO. And the result is that actually OpenStack now is a DCO community. And there was a lot more help that I could give to OpenStack behind the scenes that isn't actually public. So one of the problems that OpenStack had, I'm sure I'm allowed to say, I believe it's actually in the public record, is that the counsel who acted for the OpenStack board also acted for Apache, and it was his legal opinion that the DCO was not a valid contribution agreement under the Apache license. So the board of OpenStack was getting legal advice that said they could not use the DCO, and somehow we had to come and counteract that. And one of the things that I picked up in Linux, as I was actually chair of the technical advisory board for a long time, it gave me a huge scope to interact with lawyers. Every year I still go to one legal conference to discuss some of the open source legal problems, but it meant that my legal experience was actually very helpful, and it's not just my legal experience, it's also my experience of how do you get a lawyer to do something when they definitely don't want to do it. It's not like a dog. You can't just put a lead on them and drag them across the threshold. You actually have to manipulate them into either wanting to do what you want, or you have to line everybody else up against them and move the discussion on to being a business discussion where everybody looks and says, this is not an absolute. There is risk on one side and there is reward on the other. Prove to us that the risk outweighs the reward. That was actually how we did it in OpenStack. Although it was Mark Radcliffe's legal opinion, ultimately he didn't prevail over the community argument that this is a significant barrier to contribution. So instead of phrasing it as a legal issue, yes or no, we phrased it as a legal risk versus reward. And the risk looks fairly minimal, since by the time it was adopted by OpenStack, there are a large number of Apache communities also adopting the DCO. So Mark's legal opinion looked like it was being ignored by more than just the OpenStack people. And that helped tip the balance at the board level, and eventually OpenStack did adopt the DCO. So if I leave 10 minutes for questions, we can get on to the conclusions. There's a definite reason why community managers want you to join communities. Even though I haven't talked about it at all in this talk, because it would have been twice as long, it is the best and the easiest way of getting code upstream. If you need a long-term relationship with a community, you think you will have a long series of patches, and long can only be sort of long in terms of life cycle. For a lot of your short-lived devices, that can be 6 months to a year. Then you should invest the time in joining the community. That is the surest way of actually getting your code upstream. Whether it's in our code community or your code community, if you're a part of it, they both like you. For the one, it will assure them that you're going to be around to help maintain the code, and for the other, you're one of them, so you're part of the trusted committer circle. Definitely makes you much more likely to get your code upstream. And if, like I do, you do drive-by coding, you do have to be prepared for failures. Remember, it's not a sure thing. If I can't do it, there's lots of other people who should have no shame in not being able to do it. It is very, very difficult. There are a few strategies, as I said, that you can use to do it, like have a body of people who are willing to support your code if there's a need for it. Convince the maintainer or the community that actually your code will enhance their code base. If you get them to like your code, it's even better. So there are many, many ways of actually doing this. The number one way, the gold way, is actually personal interaction. If you can actually meet this community face-to-face and talk to them, they will regard you much better as a person with whom they've actually had social contact than an endpoint on email address who could possibly be a dog in disguise trying to troll us. So personal interaction as a drive-by coder is actually incredibly important. As witness to that, the good interactions at gnupg did not really start happening for me until I actually met Werner Koch at Kernel Recipes and talked to him face-to-face. So we've had a couple of more personal interactions since then, but the personal interaction is really what sealed the deal for him and for me in that. And also, the hardest thing can be working out why they won't apply your code. So this is the PulseAudio case. If there is a deep-seated sort of fear of your code somewhere, they can always throw up arbitrary technical issues. Arbitrary technical issues for engineers are very, very easy to manufacture. You can get a whole sequence of these that just come along one after the other, and you can address them, and okay, so they'll find another one. But the problem is not all of these issues that are coming back to you. The problem is the deep-seated problem that's sitting way, way beneath all of this that's generating all these issues. And the hardest thing can actually be working out politically what this problem is. And like I said, although I think I know what it is in Ophono, I don't know how to allay it. So even once you've worked out what the problem is, that doesn't mean it's surmountable. Sometimes these problems definitely can be insurmountable if accepting your code means that a significant chunk of the community is going to lose their code. It really is a difficult thing to do. The only way I'm going to be able to surmount this is if I can persuade the Bluetooth Consortium to deprecate HSP and we have to move to HFP. That very quickly would probably give me the leverage I needed. But absent that, it's just not going to happen. So, with that, I think we have 9 minutes left. If you like this presentation, it's all done in JavaScript, HTML5, and CSS3, which of course, unfortunately, makes me a web developer. So in addition to publicly confessing to be a Java programmer, I now publicly confess to being a web developer and also a kernel developer. And with that, I'll say thank you and call for questions if there are any. Yep. I can repeat the question back if we don't have a microphone.
So, turning this round from the other way, if you're an upstream community, are there things that you can do at relatively low cost that make life easier?
So the question is, if you're an upstream community, is there stuff you can do to make life easier for drive-by committers that don't actually cost you a lot? And the answer is yes. The first thing you can do is actually just be welcoming. Right? And this is what all of this code of conduct debate is actually about. Rejecting somebody's code is actually a personal rejection for an engineer, so you try not to do that. You should look at every patch from the point of view of, ideally, the patch always comes with a cast-iron justification of why the committer wants to do it. And so you should be able to evaluate this justification in terms of your project. And if there's a mismatch in justifications, that's where you start having the discussion over, can we firm it up? Can we make it do more stuff? Could we make it more useful to the community? If you like the justification, the next step is it's just about, do you like the code or not? Have they conformed to your coding style? And once you've got past we've got the justification in, there should be no blocker other than coding problems for the patch going upstream. And you should actually communicate that to the person who contributed it. Hey, yeah, thanks for the patch. We think this is a valid problem. The solution will actually help us. Here are several problems that the static code checker threw up in your code. Do you think you might be able to address them? Something like that. Now, it doesn't always work like that. That could have happened in the PulseAudio community, but there's a community of people there that see that accepting this code means that their code will disappear. So sometimes there can be fundamental balance issues that the project itself has to sort out. And this is where you need a good, strong maintainer to step in and say, okay, so I think this is the issue. I do believe that if we accepted this code, at some point this other piece of code would become obsolete. Is everybody happy with that? Get the issue out onto the table and actually have a full and frank discussion of it. Avoiding the issue is a characteristic of a lot of maintainers because it avoids argument. So this is probably why the PulseAudio maintainer is doing this. He doesn't want a massive fight in his community over whether we should support it this way or the other way. He'd ideally like to support it both ways. But the guys who want to support it the other way see that supporting it both ways eventually won't work. Eventually, the code that is very complex will die. And so they're unwilling to do that. So another thing that you as a maintainer if you're a group maintainership, then the group of maintainers have to do is look for these issues in your code base. Try to see if certain of the generated arguments are not arguments about the code at all, they're arguments about fundamental directions of where the project is going. And a lot of times, if an outside contributor comes with a piece of code that will actually alter the direction of your project, they can get attacked from all sides because most people are conservative at heart. They really don't like going in a different direction. They don't like the uncertainty this will bring, and that will generate an awful lot of pseudo-rejections for, this semicolon's in the wrong place, this white space is wrong, I don't like the name of that variable, and so on. But they're all substitutes for the real issue, which is the direction of the project will be changed by this patch. So as maintainers, you have to look out for that and see if you can actually do a better job of recognizing it and having the honest debate of, does this project, would it benefit this project to change course in this way? Does that help? It's not a complete answer, but it's sort of the best I can come up with. Okay, any other questions? No? If not, then I'll say thank you very much, and it was a pleasure talking to you.